So what'd you think, guys? Was that pretty awesome? So right now we're about to bring up the entrepreneurs. If you guys want to come up, and we're going to open this up for the judges to ask their questions. I know it's a tight fit, so I'm going to stand towards this end so that I'll be able to get off the stage as you guys all get up here. And so if we could just start down, we'll start down at this end since we started that end last time, and I like to be fair. So we'll start down at that end. And so here's what I'm going to just say. If you guys, we've already coached them just to make their answers, like, answer the question, don't elaborate too much, because it's only 16 minutes, 17 minutes. So just answer the question. What you'll do is just identify the company, ask the question, and they will pass microphones around. There's two. Yeah, so pass one down this way so that you guys will, yep. And I'll get off the stage. Go ahead.
Good evening. I'm Calvin Ruiz from Kennedy Space Center. The question is for Aeronide. The question is, why do we need this technology today?
Okay, the one value proposition Aeronide has is we have a one operator to multiple drones system, and we have a high level of autonomy throughout our drones. One of our pilot projects is for emergency assessment. At the Space Coast, whenever there's a rocket launch, the EOC is activated. We have to do a assessment of the entire launch area before launch, and right now what happens is the 45th Space Wing at Cape Canaveral launches a fleet of airplanes where people are flying those airplanes just to cover the entire area to make sure there's no sailboats, and there's no animals, there's no mechanical problems, etc. We can do this, save a lot of resources, a lot of manpower by having one operator operate multiple drones. Our drones are deployable automatically from stations called pods, and we basically save a lot of resources that way. Thank you.
Next. Sorry.
This is a question for Jan at Tivasol. I think your time almost ran out at the very end. You got about 10 seconds to explain how your technology solved a specific problem for NASA, but I didn't quite follow it. Can you elaborate on how your technology solves that problem?
Yeah, absolutely. So in June of 2018, NASA published a position paper from NAIC on the possibility of inducing torpor for the purpose of deep space travel to Mars. And in that paper, they described a timeline where in this year, they're studying evidence to try and do this in large animals, including the type of medications they would deliver and the temperatures that they would have those animals at. And then, starting in 2021, going straight to human studies. With our technology, we can mitigate the risks of what's unknown from transferring knowledge from a large animal to a human by inducing a state of torpor or hibernation in the individual organs first and understanding the metabolic consequences from that prior to going to human studies. Thank you.
Perfect.
Right. I was going to ask you a question as well, but I'll ask someone else since you just got one. For Articulate.
Hi.
How is your technology different than other existing, technologies for muscle nerve stimulation?
Fair question. It's really that joint modeling system that's unique. What we're doing is we're using, at least focusing strictly on the knee. We're using IMUs above and below the knee, reading and reacting to movement, basically modeling everything as forces on weight-bearing surfaces of the knee, and using that to drive particular band contraction. So there's a level of personalization that's not available with current devices, and there's a level of anticipation that's not there. Many devices currently are operating on pre-programmed stimulation sequences or are hitting on heel strikes. It's not as efficient as what we're doing right now.
CBio, do you have products on the market yet now? We don't, we're pre-revenue, but we have done one pilot with a company in Calgary where they tested our device to show that we can tell the difference between some of their genetically modified E. coli, and we have some upcoming pilots with 2 pharmaceutical companies, one called Merck and one GSK, where we're looking at, with Merck, identifying dormant HIV virus in infected cells. Problem there is, if the virus is dormant, it doesn't show the signature of infection, even though it's infected, which is kind of a bad news. And our device has the potential to identify that. And with GSK, we're identifying cell culture sterility for immunotherapy products.
And so your go-to-market plan is to sell these devices, to
Yeah,
rent them?
yeah, we have a razor blade business model. We sell hardware for a nominal fee, as well as recurring revenue from our consumable.
Thank you.
My question is for Easy and Root. Amit, how many times has your particular device been, there you go. How many times has your particular device actually been used right now? Is it on the market?
So we're currently doing a pilot testing with one of the largest security companies in Canada. So they're doing about a pilot with over 100 people within their network. And then the plan is to deploy 1,000 devices by April to spread across their dealership network and do a commercial launch by May.
Is that the particular target markets you're looking to launch into, or is that just one vertical you're testing currently?
That's just one vertical we're testing. There are the companies in about 20 plus countries. They have over 5 million subscribers, so that's a good partner to have on board to get this really out in the current market space.
Excellent. I have one more quick question for Tivasol. Very interesting technology. How long can you keep your organs preserved currently?
So we've kept human lungs on the circuit for over 2 days with excellent quality to the end. And we've done livers for longer than that, 3 to 4 days. And the other organs are developing. And for that reason, we've extended drastically the 6 to 10 hour window that we're stuck with right now. More importantly, we have an opportunity to actually intervene on that organ specifically, should there be an issue with it. For example, we've cleared out a pneumonia from a set of lungs that were full of pus.
Interesting. Last question before I move on. For Immertech, what is the NASA utilization for your technology? Could you clarify that?
Well, the idea would be to remote specialists up to the International Space Station, that whatever they need. You wanna?
Yeah, for any specialty situation. So right now we allow experts to remote into unique operating room experiences. We believe that we could do the same thing for NASA without requiring them at a moment's notice through a VR headset in our platform.
Okay, C-Bio, amazing technology, by the way, but could you give me some specific NASA examples of applications that you'd see us use?
Yeah, sure. So I know there's a lot of work to study mammalian and bacterial cells and the responses to solar radiation, which sounds like a trivial problem, but right now, a lot of times what happens is you take a bunch of cells, you expose them to different conditions, and then you study genetic modification and things of this nature, so you get one-time shot assessment of the cell, but as we know, cells are more than just their DNA. So with our solution, they'll be able to see differences as a function of time because they can continuously study the same cell. We don't harm them, so as they modify, you'll see a shift in their position and how they change.
Thank you. One more question. Soil.
Yes.
Really nice presentation. Could you tell us what you believe your NASA application might be?
One of the things, whether you're monitoring things here on Earth or one of the applications would be a stretch goal, is what's happening on Mars, right? As you need situations where power is not readily available and resources for energy is not readily available, this device can actually work on 15 microamps of just low power, right? So just small, tiny solar cells could enable us to be able to monitor sensors and report back information as needed.
All of you.
Oh, sorry.
Give him, it's at the bottom. I think this, yeah.
This one's for all of you. How many of you did a patent search? Raise your hand. Okay, all of you. How many of you had to change your claims as you did that patent search? Okay, thanks, appreciate it. A little bit.
Sure. So my first one is for Miles. So. Yay. All right. So you've already tested your thruster at NASA Glenn, which is the best place for it. And
yes.
You already have a flight demonstration on the Artemis 1 spacecraft. So what is necessary in your mind before the technology is already available for NASA to use?
Frankly, because the energy cycle is so new, we've been advised to avoid lengthy academic papers that would enable competitors and stick solely to flight demonstrations and let the data speak for itself. So we're shopping around for any flight opportunity in order to leapfrog the academic people who require proof and go for the people who take flight proof. So right now we're aggressively reaching out to universities and offering partnership opportunities. They're open, talk to us, to fly demo or get on anything in space as soon as possible.
Okay. And then for soil, so how does your system compare to Starlink? And can you clarify how your system solves the issue of 6 billion people without electricity?
So that's a compare and contrast with, this is not Starlink per se, but this is low power, low data rate communication, where if you, for instance, if it's military, you can monitor remote assets or things I talked about in my pitch as far as monitoring CO2 levels or acoustic sounds that's happening in remote areas. So this is literally kilobytes of information to just be able to report information back up and just be able to report to some database.
This question is for Amalgamated Vision.
Yes.
Given that there's light going into the retina, are there limits on the amount of usage that the device can have on the human eye, and have you done testing around that?
We have not, but there's extensive literature and experience with laser light exposed, the retina exposed to laser light. And it's a power source just like any other light. And if that is controlled and within safe limits, you can have extended exposure to laser light without any harmful effects.
Are there any other questions, any go-backs that any of the judges need to sort of answer before? Okay, go ahead.
I have one more question, same responder. You had mentioned that you had identified the technology or the wavelength 20 years ago. Could you clarify that a little bit and tell me where you are right now in the commercialization process?
We are pre-commercialization. We are pre-revenue. As a matter of fact, we don't have a product. We've built proof of concepts, and we are ready now to build our second proof of concept. We have well worked out optical designs, simulations, and we're ready to move forward. The idea was very far forward thinking 2 decades ago. It was difficult to explain to people augmented and virtual reality around the turn of the millennia, but people have caught up, and now there's more interest in it.
Same person. Okay, are you envisioning your device to be auto-loaded with data or to receive data back and forth? I'm just not real sure how
Our
you're getting the
technology is
information
a
in.
display, and it will handle any content. We think of it as a display that can provide 3D stereoscopic or augmented mixed reality. So the content would come from a secondary source, perhaps through Bluetooth, a phone or some other device that would supply the eyewear. It could always become more sophisticated with gadgets and devices connected to the eyewear itself.
I have a question for nanograph technology.
Yes.
So are you envisioning that your technology is to be licensed to a manufacturer of optical sensors or optical transmission, or you envision manufacturing the products? How do you see this going to market?
So licensing would be our initial revenue generation, but I think going into a deep licensing agreement with someone like that, like Hamamatsu, let's say, it would tie us in further developing the product furthermore, because the potential is beyond photodetectors, so we don't want to go into something that would tie us down the road. So we have manufacturing partners that are working with them and are in the process of large volume manufacturing testing basically with them. So we want to make our detectors die large volumes and then further on design the system that is going to support the photodetector and the sensor all in-house. But that's our midterm plan. Long-term, short-term is to just sell the photodetectors.
Okay, going once, going twice. Let's give them a round of applause. You guys.